constant distance from me, because I'm just standing still in my world timeline and it's just sitting there. Lines that are horizontal, lines that are horizontal to me are simultaneously occurring, but at the same point in time, because there's my time axis, so that's what that means. And for the Galilean, for what you guys saw in the pre-reading, the diagrams look like this. T prime, x slash x prime. And for this diagram, for both of the t primes, horizontal lines were totally simultaneous. And I was going to kind of describe this a little bit more. But this is a self-consistent view. This is just what it means that we're all on the same page time-wise, that our watches agree and everything's happy. But according to this guy, whereas I'm horizontal for my time, you take parallel to your slightly curved axis here for your times. So these are the lines that are simultaneous to you. Now imagine what happens here when we consider totally different points in space-time to be occurring simultaneously. We don't agree on what's happening at the same time. That's what's sourcing all of this ridiculous confusion. And it's such an insane way of thinking about this, and it requires a great deal of digesting and really formulating this. And I was really hoping that I'd be able to get around to this. But we'll do it next class. But ultimately, for the barn-ladder paradox, it's a matter of simultaneity. Because according to the barn, the front and the back doors are closed at the same time. And that's a totally different thing to the ladder. The ladder does not agree on which points are going on. The ladder agrees, okay, at one point, my front passes through the front door and the back door, and at one point, my back passes through the front door and the back door. But these don't occur at the same time, and that's because that's what they're disagreeing about, is what it means to be happening at the same time for different positions. And coming to understand how this works and how we just kind of just slant it a little bit and have something like, quite literally, a very initial observation of this graph is that what's happening way over here, this point, is way in the future for my xt axis, yet it's happening at the same time down here according to my slanted axis. You wonder why it's very easy to form these ridiculous paradoxes, like twin paradox. That's exactly how things like this get formed, because we have this sense of the future for you, or the future for me is just t equals 0 for you, even though we agree at what t equals 0 means if we're at this point in space-time. Question?
That's actually super helpful.
Is it over 10 minutes?
So the bomb would go off because the barn experiences both of the doors shutting at the same time.
Good.
Is that correct?
That is correct. Thank you for bringing that up. Yeah, so the way that I formed that question was that in the barn's reference frame, does this occur? And it does for the barn. Thus we all die. Sorry. Wasn't a very happy conclusion. If I instead put the bomb contraption on the ladder, and the ladder had some way of detecting whether or not the front and back doors closed at the same time, then it wouldn't go off, because according to the ladder, it didn't happen at the same time. And if my bomb is deciding in that, that's what matters. So thank you. That's very.
I must stop at this point because we are quite late, and you are very welcome to approach the professor right
It's
after
office hours.
Okay.